In this example, we're going to take a look at essentially this triol compound here and look and see what happens under a few different sets of oxidation conditions. So just to kind of look at what alcohols we have here, we have a secondary alcohol, a tertiary alcohol, and a primary alcohol. Okay, so no matter what oxidizing conditions you have, in general your tertiary alcohols aren't going to be oxidized. So under all of these conditions, we'll just leave this alcohol alone. Okay, and then we have a few different reagents here. We have PCC and dichloromethane, we have sodium dichromate, and chromium trioxide. So first we'll take a look at the PCC and dichloromethane. All right, and this is a mild oxidizing agent. So what does a mild oxidizing agent do? Well, like all the oxidizing agents, it's not going to affect the tertiary alcohol, but it will turn the secondary alcohol into a ketone. And it's going to turn our primary alcohol, it's just going to do one oxidation step to turn this into an aldehyde. Okay, so if we do this oxidation, we're going to get the product. We'll have our six-membered ring. We'll have our tertiary alcohol unaffected. Our secondary alcohol up here is converted to a ketone. And our primary alcohol is converted to an aldehyde. Okay, and just for reference, with your reagent here, PCC is pyridinium chlorochromate. Alright, so we have a pyridinium ion, so a pyridine like that. And then essentially our counter anion is our chlorochromate. So we have our chromium, two double bond oxygens, a chlorine, and our O minus. Okay, and this chromate is your oxidizing agent here, but under these mild conditions, we're just using this in dichloromethane as a solvent. Unlike our next two reactions, there's no strong acid involved. Okay, so our next set of conditions involves sodium dichromate and sulfuric acid. So this is a more harsh oxidizing agent. Okay, it's still not going to affect our tertiary alcohol. And like the above reaction, it's going to turn our secondary alcohol into a ketone. But now, with this primary alcohol, in the first step, we'll get an aldehyde like before, but then this will get continued to be oxidized to give a carboxylic acid. So let's take a look at the product for that. Again, there's our unaffected tertiary alcohol. Our secondary alcohol went to a ketone. And now our primary alcohol gets fully oxidized to a carboxylic acid. And really, if you looked at the reaction mechanism for this, you would see that this sulfuric acid plays a big part in converting that intermediate aldehyde to the carboxylic acid. Our last oxidation chromium trioxide in aqueous acid. This is known as a Jones oxidation. And just like the sodium dichromate oxidation, it's a harsh oxidizing reaction. So what's going to happen here is the same exact thing as in our above example, to give us the secondary alcohol going to a ketone, and then our primary alcohol going to a carboxylic acid. Just like before, that tertiary alcohol remained unaffected.